Alright, for my last video in the nomenclature unit, on page 21, which is the review, I'm going to do a number of problems. These ones named it right here: 1A, B, and C, 2A, 2D, 2I, 2M, 2O, 2P, 3A, 3C, 3G, and 3J. So here we go. I'm going to do them pretty fast, so try to keep up. Okay, 1A. What you end up seeing there is PB parenthesis C2, H3, O2, parenthesis 2. And it wants to know the name. So what you're going to do is you're going to say, okay, this is lead. It is a metal. It's transition, so it gets stock naming. This is acetate. You know, you just got to figure out what belongs in the parentheses. Well, this is 2 acetates. They're -1 and -1. 1 lead for +2. Therefore, this is lead 2 acetate. I know another name for that, so that's plum bus acetate. There's 1A. 1B. 1B says, okay, CuSO4. So when we go look at this, we say, okay, it's copper. It's a transition metal, so it's going to get stock naming. And SO4 is sulfate. Well, the charge on this is -2. Therefore, our 1 copper must be +2. This is copper 2 sulfate, or cupric sulfate. We do know a common name. You don't always have to put it, but you do for lead, copper, tin, and for mercury. That's 1B. And iron. 1C. 1C is MgSO4, a little more straightforward. So what you end up with is a metal. It's magnesium. SO4 is sulfate. The reason I didn't have to put anything in the middle here is because magnesium is not a transition metal. So there's 1A, 1B, and 1C. Let's go ahead and get the number 2 problems now. Number 2A. 2A says, ooh, we have sulfur difluoride now. First time in this review where I have shown you a problem involving 2 nonmetals. This follows covalent naming, meaning they share electrons. Sulfur is S, fluorine is F, di meaning 2, SF2. 2D. 2D is lithium nitride. So, alright, I end up telling myself, okay, lithium is Li. Now you have to read this one carefully. This is nitride. Well, the "ide" ending just is nitrogen. Nitrogen's charge is a -3. Lithium is a +1. Therefore, we take 3 +1s for the 1, -3. I get rid of my charges. Yay. 2I. 2I is cobalt-3 nitrate. Make sure I'm reading that right. Yep, cobalt-3 nitrate. Okay, so cobalt is CO. Nitrate is a polyatomic, it's NO3. This has a -1 charge. Cobalt has a +3 charge. That's why there's that 3 there. Well, how many -1 nitrates are you going to need? You're going to need 3 of them. For a -1, -1, to cancel out the +3. Therefore, you need a parentheses and a 3. Let's see, going on here. Come on in. All right, let's continue along. So we're done with 2I. So it brings us to 2M. 2M is hydrotelluric acid. So the first thing that jumps off the page at me is that word acid. I write an H immediately. Then I say to myself, okay, hydro means this anion part is going to end ide. I have something that's tellur. Okay? So I look at tellure, and I say, okay, this is telluride. Well, that's Te for tellurium, and telluride carries a -2 charge. Therefore, I need 2 +1 hydrogens. So this is H2Te. I get rid of the charges. 2O. 2O, I believe, is bromic acid. So bromic acid. Again, I see acid, so I immediately write an H. Now, I see an ick, no hydro at the front, so I know I have ick. That means it's something that's in 8. So when I look at this, I say, okay, this must come from bromate. So when I write that, that's BrO3. Now, when I look at bromate, and I look up what its charge is, the charge on bromate is, I'm trying to remember. I think it's -1. So it's +1, H3, yeah, it's HBrO3. Oh. All right, and 2P is our last one, sulfurous acid. So sulfurous acid. Again, I see the word acid, I write an H immediately. Sulfur implies just that, sulfur. I see this OUS ending, right? So that says to me, okay, there's no hydro, it's OUS end, that's something that is ite. So this has got to be the sulfite ion, SO3. That carries a -2 charge, hydrogen is a +1. Therefore, I need 2 of them again for 2 +1s to cancel out the SO3. So this is H2SO3. Okay. Let's keep going. Let's finish up. We're going to go the opposite direction now, I believe. So 3A. 3A says CuF. Well, this is copper. Is it a transition metal? The answer is yes, so it gets a stock name. F is fluoride. It's monatomic. When we look at the charge that belongs right here, fluorine is -1, therefore this copper is +1. This is copper 1 fluoride. We also know a common name for this one, don't we? So this is cuprous fluoride. +1 version of copper is cuprous. Let's see, 3C. 3C is HI. Hi. Well, I see this H at the beginning, right? So immediately I'm writing the word acid. Boom. I mean, that without saying. Then I cover up my H and I look at my I. Well, does it end ide, ite, or ate? Well, this is the iodide ion. So ides become hydro plus the base, which is iode, ic, and then the word acid. This is hydroiodic acid. So 3G. 3G is SiF4. I ask myself, does it have a metal? No, it does not. Does it contain hydrogen? No, it does not. Therefore, this is covalent, and you use the prefix system. Si, there's one of them. Therefore, this is just silicon. 4 is tetra. F is fluorine, but becomes fluoride. So this is silicon tetrafluoride. How about 3J? 3J is HNO2. So again, I see the H at the beginning, I immediately write the word acid. Then I say to myself, okay, NO2 is the nitrite ion. Ites become us, therefore this is nitrous acid. And that is all those problems done for you.